Okay guys, in our last video we talked about measures of center, or a way to describe a set of data using a single number. And we talked about mean, and we talked about median, and we talked about mode. But now I want to talk about another statistic, and I'm going to use these two students as an example of why we need more statistics than just measures of center. So if you look at student A and student B, and what I have listed are 6 of their test scores listed from least to greatest. And you'll notice that student A had a mean of 75% and a median of 75% on their tests, and student B had a mean of 75% and a median of 75%. So just looking at the measures of center, you might say that these two students are identical students, but looking at their individual test scores, you can see that they clearly are not. There's a big difference between student A and student B and how they got those averages and those medians. So the measures of center don't always tell the whole story. We can tell that student A had a wider variety of scores, and student B was very consistent, getting the exact same score on every single test. So we need some type of measure to tell us how consistent our data is, or how similar our data is to each other, or how clustered our data is to each other. And that's what we're going to talk about today. We're going to talk about measures of variability. Now, measures of variability are measures that are used to describe the distribution of data, or in other words, how spread out it is. And we've got a lot of vocabulary that we're going to have in conjunction with this. And one of those is the range. And the range, you may have heard of, is the difference between the highest and the lowest values in a set of data. So if we just look at the highest and the lowest values, we can get an idea of how spread out our numbers are. Or we can use things called quartiles, and those are values that divide a set of data into 4 equal parts. And the first quartile being the value that divides the lower half of the data in half, and the third quartile is the value that divides the upper half of the data in half. And of course, the median that we learned about last time is the value that cuts the entire data set in half. And then we'll also talk about something called the interquartile range, which we will abbreviate as the IQR. And that's simply the distance between the first and the third quartiles. And then, of course, we'll talk about things called outliers. And outliers, we usually refer to those as just any extreme values, but that's kind of subjective. So we need to have some way to define an outlier, and that's any data point that is more than 1.5 times the IQR beyond the quartiles. So again, variability describes the following things: how spread out our data is, or how consistent the data is, or how clustered the data set is. Variability does not describe where the center is. That's what our mean, median, and mode are used for. It does not describe what a typical value is. It doesn't really tell us much about the values. It tells us more about how spread out our data set is. That's important to understand. We will discuss 2 measures of variability in this video. One of them is the range, and one of them is the IQR. So first, let's talk about the range. And the range is just simply the distance between the highest and the lowest values in a data set. So in this dot plot, we have our study time, or different numbers of study times in minutes that were recorded. And we want to find the range of our data set. So it's pretty easy to find the range of a data set. We simply find the maximum value here, which was 38 minutes of study time, and the minimum, one of these guys right here, there's 2 of them that were 10, and we find the distance between those 2. So we would say the range of values here is 28 minutes, meaning there's 28 minutes difference between the shortest study time and the longest study time. And again, I want to make the point that this 28 minutes does not tell us what a typical amount of time spent studying was. Okay, that's for our measures of center. This is simply telling us how spread out the dots are on this number line. Let's take a look at another one. What is the range of weights for these letters? So we're talking about letters that were being sent in the mail, and they were measured and collected how much they weighed in grams. So what is the range of weights? Well, again, we just need to look at the maximum value, which is right here on our dot plot, and that's 58 grams. And the minimum value, or the lightest letter, was 33 grams, which gives us a range of 25 grams. So the range of weights was 25 grams from the lightest to the heaviest letter that was sent. And then the next one, what is the range of the cost of these DVDs? Now these are just listed, they're not in a dot plot, so we'll have to find the maximum value, which is $25 was the most expensive DVD, and $9 was the least expensive DVD. So the range in the cost of our DVDs is 25 minus 9, or $16. So our DVDs had a range of prices of $16. And again, this does not tell us what a typical DVD costs. It just tells us the difference between the most expensive and the least expensive DVDs. Now that's range, which is pretty simple to calculate. So that's all the time I'm going to spend talking about range. Next, I want to talk about another way to describe variability, and that is to use quartiles. Now, quartiles are values in your data set that divide your whole data set into 4 equal parts. And in the last video, we talked about a value that divides our data set in half, and that is the median. So the median cuts our data set in half, and then we're going to take those 2 halves and cut them in half again. And we're going to call those values that cut the halves in half quartiles. So I've got this dot plot listed here below, the values listed in order from least to greatest. So the median is 20. That's the value that cuts our data set in half. That's the median. And we talked about that in the last video. Now what we're going to do is going to take the lower half of the data and we're going to cut it in half again. So it's like we're going to find the median of the lower half. And the lower half of the data set has 5 values. So this value right here, this 14, is going to cut my lower half in half. And we call that the first quartile, or Q1 for short. And that cuts the lower half in half. And then we're going to take the upper half and we're going to cut that in half. And again, there's 5 values here. So this 25 is going to cut that in half. And we're going to call that the third quartile, or Q3. Now you could consider the median as our Q2, if you're wondering where Q2 is. So we have Q1, Q2, and Q3, but we just normally call it the median. We don't call it Q2. So what this does is it gives us a little bit better idea about how our most of our data is spread out. Because when you just use the range to describe how spread out your data values are, it can be misleading, because if you just have one extreme value, one really high value in your data set, that's going to make your range seem very, very big, and it's going to make your data set seem like it's very, very inconsistent or spread out. This way, we're only going to look at how spread out these values are right here between the quartiles. How spread out are those values? And it'll give us a little bit better idea about how the center of my data is spread out. So this way we're not affected by extreme values, either on the high end or the low end. So that brings us to something we call the interquartile range. Now the interquartile range is exactly what I just said. It's just the distance between Q1 and Q3. Instead of finding the distance between the minimum value and the maximum value, that's the range, we're just going to find out how far away Q1 and Q3 are from each other, and that's going to be called the interquartile range. And again, we're going to call that the IQR for short. Okay, and it says here the interquartile range is a more reliable measure of variability when there are outliers, because it only describes how spread out the middle half of the data is, whereas the range is dramatically affected by outliers. Our IQR will not be affected by outliers at all. So let's try to make sense of this picture that I have here. So I've got a data set plotted on a dot plot here, and you can see my minimum value is 13, and then I have a bunch of other values that are kind of clustered here between 19 and 24. Our maximum is also 24. So I want to show you what the difference between the range and the IQR is. So in green, I have my minimum and my maximum values. So my maximum value is 24, and my minimum value is 13. This gives me a range of 11. That tells me that there's 11 numbers between the minimum and the maximum values in this data set. That's a little bit misleading because you can see that the majority of my data is probably closer to being within 4 or 5 of each other rather than that one value that's way down here on the left that's kind of making it look like all my data is spread out. So now we're going to look at the IQR. So to find the IQR, I found the median, which was 21. That's the middle number when they're all listed in order from least to greatest. So I kind of wrote it two different ways here. I've got the dot plot, and then I've got just the raw numbers in order from least to greatest. So whichever one makes more sense to you. So our median, 21, cuts all of the values in half. And then on the lower half, I'm going to cut those in half again and get Q1. So my first quartile is 20. And then my upper half is cut in half by the value of 23. So my Q3 is 23. So my IQR is going to be Q3 minus Q1. It's going to tell me how far apart these two values are. And that's 23 minus 20, which is 3. So we can see that that's a much smaller value, and it makes a little bit more sense to say that most of my numbers are kind of clustered within 3 of the median. So if I look at the median and then I go up 3, that gives me 24. And if I go down 3, that would give me 18. So really all of my data is within 3 of the median, except for that one outlier that made it look like all my data was spread way out. So that gives us an idea or a picture of how IQR is a little bit more reliable than range. Range can be dramatically affected by outliers. So interpreting measures of variability, what does it mean? How do we read these numbers? If they don't tell us what a typical value is, then what does it tell us? Well, it tells us how consistent our data is, how spread out our data is, or how clustered our data is. So when your range or your IQR are small, that means your data are very consistent. They're very close together or clustered. Or we could say the data doesn't vary. Okay, it doesn't, the numbers aren't that different from one another. And the smallest value you can have is 0. If all of your numbers in your data set are identical, your range is going to be 0 because your max and min are going to be the same number, and your IQR is going to be 0. So that's the smallest you could possibly get. So the closer you get to 0, the closer you are to having identical numbers, which means the more consistent your numbers are, or the more alike your numbers are. When your range or your IQR are large, that tells you that your data is inconsistent, or it's very spread out, or the data varies greatly. So when we're interpreting our measures of variability, it's very important that we keep those ideas in mind so that we don't accidentally get them confused with measures of center. They do not tell us what a typical value is. It only tells us how spread out our data is. So let's take a set of data here. We've got some airplane tosses, and we measured how far Marley was able to throw his paper airplane after 2, 4, 6, 8 times that he threw it. So we want to know how consistent his paper airplane is when he's flying it. So we're going to find both of the measures of variability for this data set. We're going to find the range, and we're going to find the IQR. So the range is simply the max minus the min, our largest value minus our smallest value. And again, I took the values from the table and I listed them in order from least to greatest. So our maximum value is 53. And the minimum distance that he threw his paper airplane was 25 feet. So that gives us a range of 28 feet from the shortest to the longest throw. Now the IQR takes a little bit more work, but it's pretty easy to do once you get the hang of it. So to find the IQR, we need to find Q1 and Q3. So we need to cut our data into 4 equal parts. So the first thing we need to find is our median. So to find the median, we count how many data values we have, and we have 1, 2, 3, 4, 5, 6, 7, 8. So that means 4 and 4. So we'll cut it in half, and my median is right here at 42. That'd be halfway between 40 and 44. So now we're going to cut the lower half in half, and there's no number there. So again, we're going to have to find what's between 38 and 39, which is 38.5. This is my Q1. And then halfway between 45 and 49 is going to be my Q3, and that's 47. That's my Q3. So my IQR is going to be Q3, the third quartile, minus the first quartile. And that's 47 minus 38.5. And that gives me an IQR of 8.5. So most of my values are within 8.5 feet of the median. Lastly, we're going to look at identifying outliers in a data set. So to do that, the first thing we're going to need to do is calculate the IQR. And then secondly, we're going to take the IQR and we're going to multiply it by 1.5. And let's let this value be X. And then thirdly, any data value that is greater than Q3 plus X or less than Q1 minus X is considered an outlier in a data set. So let's take a look at an example of how to calculate whether we have an outlier or not. In this table, we have the running times of 8 movies in minutes, and I have them arranged in order from least to greatest here so that we can find our IQR. The first thing we need to do is figure out what our IQR is. So I'm going to have to find my median, and that is right here. My median is 112.5 minutes. And then the lower half of my data, if I cut that in half, my Q1 is going to be right here, halfway between 100 and 105 minutes, which is 102.5 minutes. And then the upper half cut in half will be my third quartile, or Q3, which is 120 minutes. So to find my IQR, I want to know the distance between these two values, Q1 and Q3. So I take 120 minus 102.5 to get an IQR of 17.5 minutes. And then secondly, I want to multiply that IQR by 1.5. So if I take 17.5 times 1.5, I get 26.25. Now this number right here, I'm going to use to find out whether a value is an outlier or not. So any number or any data value in my set that is greater than 26.25 minutes above Q3 or 26.25 minutes below Q1 is going to be considered an outlier. So I need to find my cutoffs for that. So I'm going to take Q3 plus that 26.25, and Q3 is 120. So 120 plus 26.25 is 146.25. So any data value that is greater than 146.25 minutes is going to be considered an outlier. And then I'll get my low end, Q1 minus 26.25. And Q1 was 102.5. And I subtract 26.25. That gives me a lower limit of 76.25. So any data value that is below 76.25 minutes is going to be considered an outlier. So looking back at the data set, I don't have any value that was less than 76.25 minutes. The shortest movie was 96 minutes. So 96 would not be considered an outlier. And then on the other side, any value that is greater than 146.25 minutes is going to be considered an outlier. And we actually do have a movie that was beyond that limit. So we would say that this movie right here that was 155 minutes is considered an outlier in this data set.